All right, here's our table work. Remember, we're looking at 3 types of functions. Let's see what this first one is. Do you see how it's a decreasing function? And we notice that it's being divided by 3. So what do we say? We say times 1/3 as the multiplier to the previous term. And so we'd say that this function is exponential. Okay, then we go write the explicit and the recursive. Begins with 243 timesing by 1/3 to the power of x plus 1, because it's x minus a -1. Recursive goes f of -1 equals 243. F of x equals f of x minus 1 times 1/3. Okay, how are you doing on those? Remember that you could have used a different coordinate pair instead of the -1 to 43. If you wanted to write it using the 0 term or the first term, you could have, but it would have changed a couple numbers on those. Let me know if you have questions on the way you answered it. Okay, I'm going to jump here to the end because this one's a little bit quicker. You'll notice this one is adding 9 each time. So we would say this one is linear because sorry, this is hard to read. Adding a common difference each time. So my explicit goes like this, begins with 93, adding 9 every time to the x minus 12. Where does that 12 come from? This 12 comes from right up here. This 93 comes from right here. And the plus 9 comes from right there. Recursive, f of 12 equals 93. F of x equals f of x minus 1, plusing 9 each time. How'd you do? Okay, last but not least, if I do 18 minus 43, I'm going to get that it's going down 25. 3 minus 18 goes down 15. -2 minus 3 goes down 5. And then that means that this is now going up a constant second difference of 10. Okay, type of function, therefore, is a quadratic because it has a constant second difference and a linear first difference. The explicit. We start with a base of an x squared, and then we know that if the common difference is a plus 10, that my number, my coefficient in front of the x squared is half of that. So this is a 5x squared. And we can also see that the y-intercept is 2, negative 2, excuse me. And so that just puts that negative 2, that minus 2 right here at the back. The recursive, f of negative 3 equals 43, f of x equals f of x minus 1 plus, now I'm looking for the linear first difference. In order to add here the recursive linear first difference. So we go up to the top, and remember how we do the pick a row, any row work? So begins with negative 5, adding 10 every time to the x minus times 0. We simplify this down and get 10x minus 5. Or what if we had used a different row? Begins with negative 15, adding 10, x minus a negative 1. That becomes plus 1. So 10x plus 10, negative 15. Negative 15 and 10 makes the minus 5. Both of these yield the same linear rate of change, and that's what we add here at the end of our recursive, plus 10x minus 5. Some people started to notice this pattern of the plus 10 plus 10 plus 10 is going to give me a 10x minus half of that.